Did you know that in our Milky Way galaxy alone, there are estimated to be at least 100 billion planets? But how many of these could potentially support life as we know it? The Milky Way, our cosmic neighborhood, is a swirling galaxy teeming with countless celestial bodies. Among these are planets, some of which have characteristics eerily similar to our own Earth. We call these Earth-like planets. But what makes a planet Earth-like? It's not just about looking like Earth, it's about potentially being able to support life. There are several factors to consider, such as the planet's distance from its star. Too close, and it might be too hot. Too far, and it could be too cold. The planet's size is another factor. It needs to be just right to hold an atmosphere. And of course, the presence of water is a crucial element. So, let's dive deeper into the fascinating world of Earth-like and habitable planets. Picture this. A planet much like our Earth, orbiting a distant star. Exciting, isn't it? But what exactly makes a planet Earth-like? Well, it's a combination of several factors. It starts with the planet's size and mass. It should be roughly similar to Earth's, to support a stable atmosphere and a surface gravity that could potentially sustain life as we know it. Then there's the Goldilocks zone, or the habitable zone. This is the just right distance from a star where a planet might hold liquid water, an essential ingredient for life as we know it. Too close to the star, and any water would vaporize. Too far away, it would freeze. Now let's talk about a few of the known Earth-like planets. First up is Proxima Centauri b, the closest known exoplanet to us, located in the habitable zone of the star Proxima Centauri, just over 4 light-years away. It's slightly more massive than Earth and orbits its star every 11 days. Then there's Kepler, 452b, a planet discovered by NASA's Kepler Space Telescope. It's over 1,400 light-years away and orbits its star, similar to our Sun, every 385 days. Its year is just about as long as ours. But how do we find these distant worlds? The answer is through a lot of patience and highly sophisticated technology. Space telescopes like Kepler and TESS look for tiny dips in a star's brightness, which could indicate a planet passing in front of it, a method known as the transit method. Other times, scientists use the radial velocity method, where they observe small wobbles in a star's position caused by a planet's gravitational pull. Both methods require careful observation and analysis, but the payoff is extraordinary. Potential second homes in the cosmos. These distant worlds, eerily similar to our own, spark curiosity and fuel our quest for discovery. But Earth-like doesn't necessarily mean habitable, so what does it take for a planet to be truly habitable? Well, let's delve into that. A habitable planet, in the simplest terms, needs to be able to support liquid water. That means it has to be at a certain distance from its star, not too close lest the water boils away, and not too far, where it would freeze. This region is known as the Goldilocks zone, where conditions are just right. But being in the Goldilocks zone is just the beginning. The planet also needs to have a suitable atmosphere, one that can regulate temperature and protect potential life from harmful cosmic rays. Now let's consider a few examples. Take Kepler 22b, for instance, a planet that orbits its star at a perfect distance. It's in the Goldilocks zone, but there's a catch. We're not sure whether it has a suitable atmosphere or even a solid surface. It could be a water world, or it could be a gas giant like Jupiter. Another fascinating world is Gliese 667cc. This planet is roughly 4 times the mass of Earth and is located in the habitable zone of its star. It receives about 90% of the light that Earth does, which could mean it supports liquid water. But again, we're left with questions. We don't know its atmospheric conditions, and its larger mass could mean a much higher surface gravity than we're used to. These examples highlight the challenges in defining a planet as habitable. It's not just about being Earth-like. A planet needs the right conditions, the right atmosphere, and the right location in its solar system. And we're still learning what right really means in this cosmic context. As we continue our search, we're bound to uncover more about the intricate balance that makes a planet habitable and perhaps home to life as we know it, or as we can't yet imagine. It's intriguing to imagine that these habitable planets could potentially be cradles of life, isn't it? Our cosmic hunt for Earth-like and habitable planets continues, fueled by our innate curiosity and technological advancements. This quest is not a mere chase of celestial bodies, rather, it's a pursuit of knowledge, understanding, and perhaps companionship in the vast expanse of the cosmos. In this endeavor, our technological triumphs serve as the eyes and ears in the farthest reaches of space. Instruments like the Kepler Space Telescope have been instrumental in our search, identifying over 2,000 exoplanets since its launch. Kepler's successor, the Transiting Exoplanet Survey Satellite, or TESS, continues the legacy. It scans the skies with an even keener eye, hunting for telltale dips in starlight that may indicate the presence of a planet. The future holds even more promise. Planned missions like the James Webb Space Telescope, set to launch in the coming years, will provide unprecedented detail and sensitivity, further enhancing our ability to spot potential homes away from home. This unending exploration isn't just about finding new planets though. It's about understanding the conditions that make a planet habitable. About discerning the delicate balance of elements and energy that allows life to flourish. It's about searching for signs of life as we know it, and perhaps, life as we don't. Each discovery brings us one step closer to answering the age-old question, are we alone in the universe? The cosmos is vast and full of mysteries waiting to be unraveled. Each star we gaze upon could be a sun to another Earth, each galaxy a testament to the grandeur of existence. Our thirst for knowledge propels us into the great unknown, fueling our curiosity and painting our journey with awe-inspiring discoveries. The importance of space exploration and scientific curiosity cannot be overstated. Join us on this fascinating journey through the cosmos. Subscribe to Infinite Space and let's unravel the mysteries of the universe together.